we're going to be looking at simple harmonic motion. So simple harmonic motion is something that is periodic in nature, which means it repeats itself. For example, the oscillation of a pendulum, the orbit of a satellite, or the vibration of a tuning fork. All of these can be modeled by sinusoidal, which means sine or cosine curves. So we are going to be using a calculator to do this. So the first thing we need to do is read our problem and use this to draw a sketch of the motion. So we have a weight that's at rest hanging from a spring like this. It's pulled down 6 centimeters and released, and then it goes up and down, completing one cycle every 3 seconds. So we're going to graph this on our coordinate point. So our y-axis is the position of the weight, which, because it is pulled down 6 centimeters, we know this is going to be in centimeters. And our x-axis is time, which is going to be in seconds. So because it's pulled down 6 centimeters and released, that means it's starting 6 centimeters below its resting point. So this is where it's resting. This is where it starts. So if it's pulled down 6 centimeters, that means its highest point is also going to be at 6 centimeters. So this is telling us our amplitude right now. So if it starts down here, it's going to go up and then back down. This is going to be one complete cycle, right? And we know that one complete cycle is 3 seconds. So looking at this, we can already tell it starts at the bottom, right? And this is one cycle. So this is clearly a negative cosine function because it's starting down here. We know that our amplitude is, it goes up and down to 6, so your amplitude is 6. Our period from here to here is 3, but we of course still need to find b. So to find b, we're going to do 2 pi divided by my period. So my b value is 2 pi over 3. So I'm going to write this as an equation. So I have f of x. It's a negative cosine. So I have negative, my amplitude is 6 cosine, and then my b value is what goes next. So this is 2 pi over 3. And again, I have an x value. So this is what I'm going to be plotting in my calculator. So when I put this in my calculator, the first thing I need to do is make sure that we are in radian mode. So make sure that you have your calculator in radians, and then go to y equals. So when I'm graphing this, you're going to type in -6 cosine. Notice that after the cosine, it'll give you a parentheses. You can't change that, so you're going to have a parentheses right here, which means you're also going to need one to close out your function. I'm actually also going to put my x in parentheses as well, because when we start graphing horizontal and vertical shifts, that's going to be important. So what this is going to look like is I'm going to have my b value, 2 pi divided by 3, open parentheses, x, close parentheses, close parentheses. So on my y equals screen, this is exactly what I have written right here. Okay. To make sure that I'm going to see this correctly, I'm going to go to window. So press window. So right now, it doesn't matter what you have on there. What we want to see, here's our x-axis. We want it to start at 0. So we want our x minimum to be 0, because you can't have a negative time. My x maximum, so I only really need to see one cycle. So I'm going to say that my x maximum is 3, because that's the end of the cycle. So I'm going to change my x max to 3. For my y minimum and y max, so it's going from -6 to 6. I want to just add on a little bit more space so I can see it better. So let's make our y minimum -10 and our y maximum 10, just so we can make sure we can see the whole graph. So 0, 3, -10, and 10. I'm not going to change my x scale, y scale. So now when I press graph, I should see a picture of this graphed on my screen. Which, yep, this is indeed, here's one cycle. It's a negative cosine. And it starts at -6, goes up to 6, and back down to -6. So we're not going to use this graph on our calculator to answer 2 more problems. So part C is asking you, what is the position of the weight at 1.5 seconds? So seconds is clearly your x-axis. So we're trying to figure out when is x 1.5. So to do this, I'm just going to go to trace. So this is the button right next to graph. And right now, if I type in 1.5, it's going to appear right here underneath my x equals 1.5. Press enter, and it'll tell you what your y value is. So this one's a little bit hard to see, but so when x is 1.5, my y value is 6. So the position of the weight at 1.5 seconds is y equals 6, and because it's my y value, I know it's in centimeters. Part D is asking us to find the time when y equals 3.5. So this time they're giving us our y value. To do this, we're going to go back to our y equals. And so I'm actually going to put y2, so don't clear off this equation. I'm going to go down to y2. I'm going to type in 3.5. I'm going to push graph, and it should graph a line at 3.5. Now this part is really important. It's really important for you to read this problem because this is asking you use the graph to find the time when y equals 3.5 for the first time. So notice this graph actually crosses the line 2 times, one right here, one right here. We're looking for the first time, so we're looking for this one right here. To do this, I'm going to go to second trace, so the calc button. So second trace, and I'm looking for where these two graphs are crossing, which is your intersect. Go down to 5. And now I'm going to push the arrow buttons until I can get to right over this point where they're crossing. So I want my cursor to be right over that intersection point. It's going to ask you first curve, you're going to press enter. It's going to say second curve, you press enter. Yes, you press enter again. So you should be pressing enter 3 times and it'll tell you where the intersection is. So here your y value is 3.5, which is what we want. And now our x value is 1.04737778. Just like before, we're going to round this to 3 decimal points. So this is 1.04, and then the 3 tells you that you keep the 7 as a 7, don't round it to an 8. And because this is your x value is time, which is seconds. So yes, it's very important that you have units. Okay, let's look at the next problem. The depth of the water off a certain pier in Port Aransas, Texas, reaches a high tide of 3 meters above and a low tide of 3 meters below the sea level. The time between high tides is 14 hours, and high tide occurs at t equals 0. So let's first label our graph. X again is time. This time it's in hours. And this is the position of your tide. And this is in meters. Again, they're telling you high tide is at 3 meters, which means the highest point it reaches is 3. The lowest is at -3. At t equals 0, so the beginning point, that is when it's high tide, which means it's starting up here. So let's draw our full cycle. This is one period. It's telling you that the time between high tide, so from one high tide to the next high tide, which is your period, is 14 hours. So this is 14. Okay, so it's clear to see from this, your amplitude, highest to lowest, is 3. Right, so it goes up to 3, down to 3. Your period is 14. So to find our b, we're going to do 2 pi over 14, which we can simplify to pi over 7. And if it starts at the top, goes down, back up to the top, I know that this is going to be another cosine graph. So I'm going to have amplitude, cosine, and then my b is pi over 7. And then, of course, don't forget your x. So now we're going to graph this again. Let's go to our y equals, clear this out, type in 3 cosine pi divided by 7, open parentheses, x, close, close. And let's go to our window. So this time for my x, I want it to go from 0 to 14. For my y, I want it to go from -3 to 3, but let's just make it a little bit bigger so we can see the whole thing. I'm going to change it to -5 to 5. So it doesn't matter exactly what it is as long as you can see the entire graph. So when I graph it, yes, this does match my picture that I drew, which tells me that I wrote my equation correctly. Okay, let's look at C. What is the depth of the tide after 12 hours? So hours is your x value. So we're looking for x here, which means I press trace and then just type in 12. And it'll tell you, okay, when x is 12, y is 1.8704. So I'm going to round that to 1.870. And your y value is in meters. Don't forget meters. Now for part D, it's asking you to find the first time that the depth of the tide, so the position of your tide, is 1 meter. So this is my y value now. So y equals 1, which means I'm going to go into my y equals, go down to y2, type in 1, press graph. Here again I see the line. There's 2 intersection points. Which one am I going to pick? The first one, because this is the first time. So I'm going to go to second trace. I'm going to go down to intersect. And then I'm going to move my cursor so that it is over this first intersection point. And then press enter 3 times. And it tells you my intersection. Here's when y is equal to 1. My x value is 2.74. And because after this 2 is a 7, we're going to round it to a 3. So 2.743, this is my x value, so that is hours. Okay, we're just going to do one more example just with drawing the graph and writing the equation, because this is the most important thing. It's the first thing you do. If you can get the graph right and the equation right, then the rest of this is just using your calculator. So we have a weight that is at rest hanging from a spring. The weight has a maximum displacement of 3.5 inches and completes 1 cycle in 5.7 seconds. So we are also going to assume that the weight is at rest at t equals 0 and oscillates up first. So this is clearly a typo. This is where we're graphing the position of the weight, and it's in seconds, not hours. So change that. Now we're going to use this, our time is again on our x-axis. This is in seconds. This is the position of the weight. And this is in inches this time. The maximum displacement means that that's telling you it's going up or down 3.5, negative 3.5, which tells you that is your amplitude. Because the weight is at rest at t equals 0, which means it hasn't moved at t equals 0, this is one where it's starting at the origin. If it oscillates up first, that means it's first going up and then back down, and this is one complete cycle. Right, so this is already telling you that this is going to be a sine function. We know it's going to be a sine function. And it tells you that the 1 cycle is 5.7 seconds, which means your period is 5.7, which means our b value is 2 pi divided by 5.7. Because we're putting this in our calculator, we're not going to worry about this decimal. We're just going to leave it like that. So to write our equation, we have f of x equals amplitude, which is 3.5. We know this is a positive sine function. Our b value is 2 pi over 5.7. And then we have x. So let's put this into our calculator. We have 3.5 sine 2 pi divided by 5.7, open parentheses, x, close parentheses, close parentheses. So this should look exactly like your equation. Let's check to make sure we graphed it right. So go to your window. X minimum is 0. X maximum, I'm going to make 5.7. For my y's, I wanted to go from negative 3.5 to 3.5. So I'm just going to leave it as negative 5 to 5. So again, I can make sure I see the whole graph. When I press graph, Now I should get a function that looks just like the one that I drew on my paper. And that tells me that my equation is indeed correct.